We have some blanks to fill in. A left Riemann sum is an overestimate of the actual area if the function is strictly... This is a left Riemann sum that was an overestimate. We colored too much. We colored outside the lines, right? Colored beyond the function. What was this function? Increasing, decreasing, concave up, concave down? Okay. Decreasing, concave down. Did the concavity determine any of that? It's just simply the fact that it was decreasing. So concavity had nothing to do with it. In this case, it is simply, and let me use the purple pen, I don't know why, decreasing. A left Riemann sum is an overestimate of the actual area if the function is strictly decreasing, okay? A left Riemann sum is an underestimate of the actual area if the function is strictly, check this out, the function was going up, there's a lot we didn't count, so increasing. We're going to get to the concavity on midpoint, but that's a tricky one. Right Riemann sum is an overestimate of the actual area if the function, okay, this right Riemann sum was an overestimate. The function is increasing. And you can see where this is going. Here's the front of the notes. A right Riemann sum is an underestimate if the function is strictly decreasing. There's a lot we didn't count. Okay, now we get to the fun one. A midpoint Riemann sum is an overestimate of the actual area if the function is strictly, okay, increasing, decreasing has nothing to do with this. It has everything to do with concavity. And I'm going to give an exaggerated example of that. And here it is. We're going to find the area of this curve, excuse me, on this interval from 0 to 1 using one midpoint rectangle. Okay, pencil time. I want to estimate this. I would go up till I hit the function, and that's it. I am estimating this area using one midpoint rectangle. Okay, so if this was like 1, this would be 1/2, and I would go up at 1/2 till I hit the function and I go over. Okay, clearly an underestimate. I have an underestimate if we are concave up. That was not the blank I was supposed to fill in. Oh well, we'll go with it. A midpoint Riemann sum is an underestimate of the actual area if the function is strictly concave up. You can see where this is going, but let's make sure we understand it. I'm going to go ahead and write it down. Concave down is going to be this one, but let's understand it. And if you want to understand it this way, you can. So here goes 1. And then we'll say that this is 1/2. We'll do one rectangle to estimate this area. But if I do that, I'd go up to here, which looks like kind of a maximum. And that is shading too much. I'm shading outside the lines. And therefore, that's why.